Hey folks, Quill18 here and welcome to another Unity 3D tutorial. So to continue from the last one where we showed you how to do a first-person shooter, the actual shooting, where we can destroy things instantaneously, and obviously lots of placeholder graphics. But as I said, I have a complete game, a complete multiplayer first-person shooter. The source code is all available. You can see the video for that if you check my channel, and look down below for links to the downloads to that project and also the actual video itself. But so we've got sort of machine gun code set up right now. So if I go somewhere, I can just hold down the mouse button and things will just fire over and over and over again. But what we want to do this time is make a projectile-based one, basically how a rocket launcher would work. So we're going to use the same code. We're just going to put in a special little catch in there where we're going to have another placeholder. And this is going to be the projectile prefab. And this is what we're going to spawn when we shoot. Well, do we want to use the same code? Yeah, why not? You know what we're going to do? We're going to break out some of the stuff into functions. So if there's a projectile, gosh, this would actually be a really, really good time to do subclassing and things like that to not dirty up this code. You know what? I changed my mind. Just to keep it a little bit cleaner for people, I'm going to duplicate this script. I'm going to call it, instead of performs attack, I'm going to call it performs attack projectile. So now I'm going to open this. And actually on my first person controller, so I'm going to remove the old perform attack script. And I'm going to put performs attack projectile on there. We also have to rename this, projectile. You've got to rename the class, otherwise it won't work. Again, all this code will be available for download. So here, we actually don't need a range. We still need a cooldown, but it should be a much slower cooldown by default. And we don't even need the damage. A lot of this is going to be quite different and we don't need a debris prefab. All we need is a projectile prefab. And our code is going to be significantly simpler as well, because we don't need to do a raycast anymore. We can get rid of all of this. All we're going to do is we're going to instantiate the projectile prefab. This is going to be a rocket. Instantiate it. The position is going to be based on our camera.main.transform.position. And the rotation, again, is going to match the camera. Camera.main.transform.rotation. It's going to be completely aligned with our camera. And that's it. That's our entire shoots code. The rest of it is all going to happen in the projectile itself. So we're going to have to create a new object, and I'm going to create a capsule for this, or yeah, capsule. Capsule should work fine. So we're gonna make it a fair bit smaller. I'm gonna make it rocket sized, and maybe half height that way. And let me rotate it by 90 degrees this way. All right, that seems like a fairly reasonable size for a missile. It's certainly going to be very, very noticeable. So we're gonna rename this, or rocket rather. I'm gonna rename this rocket, make it into a prefab. And what kind of behavior is this thing going to need? Well, so this is I don't know. Well, I don't know. It needs a couple of things. It needs a rocket engine. And you probably want a more generic name for this, but what the heck, we're going to use this. Rocket engine. It's going to be very simple. This is going to have a speed. Public, float, speed, and it's going to move at, maybe 10 units per frame. And on fixed update, we're going to go transform dot translate. And we're going to move it in our transform.forward direction times speed times time.delta time. All right, we want to move it based on that. So that is literally our rocket engine. So we've got that script on there in our first-person controller. We are going to take the rocket prefab and put it in the projectile prefab. We're going to change the cooldown time to 1. I can actually get rid of my rocket from the screen. And now if I click, we spawn the rocket. Now it does have the problem that it is not rotated, and that is a pretty common thing to happen. Let me take this rocket and put it back in the world. So I rotated this object, but that is not going to maintain when it's spawned. When I instantiate it, I could give it a rotation, Like, I could take it 90 degrees from there. Listen, don't mess with that. Take your model, stick it inside an empty game object. Okay, this is going to be the actual rocket, whereas this is going to be the rocket model. And the rocket model is going to be inside the rocket. We're going to take the rocket engine, we're going to remove it from the model side. Also, we want the model to be exactly at the 0 coordinates of our container. Put the rocket engine script on this. We can delete this prefab, recreate it like that, go to our first person controller and put the rocket on there. Okay? I hope it's never a good idea to have your model be the root object and to try to attach scripts to it. Just never do it. I've said this before in other videos. Literally never do it, because you're going to run into this sort of nonsense all the time. Always put an empty game object, put all your logic on there, and then put the model inside of it. That way you can also rescale it. Like, I can take this and change the size of this object just fine without messing up some of the other things. Let me undo that. And anyway, listen, it's just going to work way, way, way better. Let me get rid of this rocket, hit play, and then try shooting again. Whoops. Projectile prefab's not been assigned. I thought I did. Was it running maybe? That's possible. All right, it's not quite there. Why is that? I think it's because, oh, the translate. Translate uses, trying to remember what coordinates it uses. I guess it uses it relative to self, and we want relative to world. There we go. So I can just hold down the mouse button and I start firing rockets. Now, zoom out over here in this view. There, not bad. Now, of course, they're just passing through everything right now, but that's the next problem. The other way I could have done this is instead do something like transform. Why is it doing that? I hate when it like breaks the autocomplete. Transform.position plus equals. Well, actually, I think it would have to be equal transform.position plus all that code. So either way works totally fine. So there we are. All right, so that is the rocket engine, but of course we want a warhead on there, right? So let me drop my rocket back in the world so we can investigate this. One thing you'll notice, of course, our model, because this is the default Unity components, our model comes with a collider on it. We really do not want this collider to be on our model. We want to remove this. Again, the model should just be the visual effect. We're going to want a collider on the base object. What's nice about that too is it can make it, again, a little easier. If you're swapping out the model, you're not worried about losing your collider. So we will continue to use a capsule collider though, because that works just fine. We'll set the radius to 0.1-ish and change the direction so it's along the Z axis. So it's aligned with our shape. There we go. That looks good. Now, collisions are very interesting in Unity because there is a certain, there's a matrix that determines what can collide with what. And the trick is, you're used to thinking, because we want it so that when the missile collides with an object, that it detonates and does damage to the object, right? The thing to remember is that collisions, the literal word collision, only happens if you're using rigid bodies, if you're using actual physics, okay? Collision means physics. Only in the context where you are using the physics engine and that you want this to literally be like able to just sort of bounce off like a ping pong ball, that's the time you use collisions. The rest of the time, you use triggers, right? This is a trigger. This is not paying attention to the actual physics system. It could. I mean, we could have it run entirely within the Unity physics system and use forces and all that. It's frankly not appropriate for this particular implementation. In yours, it might be, but for us, it's definitely not. So that's number one, is we want a trigger. The other problem is that, again, because this does not, it's not a real physics thing, it will not trigger against static colliders. And you know what we can do? We can do some tests to see that for sure. So in our rocket, we have a rocket engine. We also want to do something like add some sort of warhead script. okay? Or detonates on hit. So when this collides, collides in air quotes, it's going to detonate. Come on, load up. So there's two possible functions that we can run for this. There's void on collision enter, and there is on trigger enter. And as is, we're actually not going to do either one of these. We will do a debug.log and another one over here, and this is going to be trigger enter. Neither one of these will trigger. So I'm actually going to leave this rocket in the world here. It is perfectly aligned with this red box, so if I hit play, no, that's fine. If I hit play, it should go right through the box without meaning to shoot. Yep, but nothing triggered. And the reason is that things that are triggers don't collide against static objects. Well, you'll say, what if I take that off? Still nothing. And again, this comes into the idea of rigid bodies. Well, what if I put a rigid body on here? Well, excellent question. Let's put a rigid body on here and hit play. Now, all right, it very clearly smacked up against things. And that might be what you want. The problem is that right now we are using our rocket engines. We're just translating the transform. And you never want to do this with rigid bodies because the rigid body physics, this is just going to mess up all the things. What you could do instead is replace this with, take the rigid body, add force, and add, well, basically this kind of force to it. It's just going to move forward like that. But it also means that if this is a rigid body, it's also affected by gravity by default. Now, yeah, you can turn off the use gravity and so on and so forth. But the point I'm trying to get is that the physics system is way too complex and does too much for our rocket. It's literally not what we're looking for. We want to use the transform translate. We just want to move forward in one direction in a straight line. We don't, we're not going to incorporate drag or wind resistance or anything like this. No way. Come on. This is a first-person shooter with rockets. Rockets work very, very simply. They just move in a straight line, and that's all there is to it. You could have it accelerate. That's true, but you could do that here as well, right? You can have your speed go up by a certain amount on every frame if you want acceleration. That's okay. We can do all these things. But we did like the fact that it actually collided. So what's the answer? Well, the answer is to say, first of all, that this is kinematic. We'll leave the rigid body on there. Because one of the things is, again, these triggers will never collide with anything that's just static geometry. So it has to have this sort of kinematic rigid body so that it tracks some of these triggers. The other thing, too, is you actually, anything that's a static collider, so it's got a collider, but it doesn't have a rigid body attached to it, you actually never want to move that stuff in Unity because it actually forces, because Unity assumes that something that is static will never move. So if it's got a collider and no rigid body, Unity assumes that this will never move, and so it creates a sort of static collision mesh. It pre-calculates that helps to optimize things. But if you start to move that stuff around, then it has to constantly recalculate that entire static collision mesh. So it's a bad thing. By putting this as a kinematic rigid body, then Unity will not try to build a static collision mesh using this object. So you actually get better performance if this is something that moves. It's actually a better idea. So let's hit play and see where we're at. Oops, let me clear. Now look at that. We're getting an on trigger enter at this point. This is a static collider. This is not a static collider, but having it be a kinematic rigid body works. If I turn off the is trigger though, check this out. Okay. So again, we're looking at that matrix. I know it's getting confusing. Now we've got, it's a kinematic rigid body with a collider, not a trigger. Collider, we're going to hit play. Nothing. See this? No entry at all in the console log. But by having it be a trigger and have it be kinematic, now it can smack into things. And let me tell you, this took me a long time to really drill into my head properly. Anything that wants to trigger either a collision response or a trigger response, just assume right away, it needs to have a rigid body. If it's going to trigger any kind of interaction between objects, in terms of collisions. It needs a rigid body and it needs a collider. The question is simply, are you using the physics system to do it, in which case it is a normal rigid body with a normal collider, or are you moving things on your own through script logic, in which case it should be a kinematic object that is a trigger. And then, of course, in your script, you also need to use onTriggerEnter instead of onCollisionEnter. Right? OnTriggerEnter is now firing. I realize that it's a weird, wonky difference, but you got it. Otherwise, things aren't going to collide. And this was actually a problem 2 or 3 Ludum Dares ago, where I did the first-person Godzilla game where you're playing as Mecha Kittanzilla. I didn't have this matrix kind of figured out properly in my head, and I had missiles, and the missiles would actually hit Kittanzilla quite effectively. Everything would work fine that way, but it wouldn't hit the ground. It would go through the ground and then continue sort of flying around, which would be weird and wrong. So, and it's because I hadn't sorted this out properly. And in fact, if I take this and I rotate it downwards and I hit play, it should smack into the ground. Boom, OnTriggerEnter, it properly detects when it hits the ground. So everything is working exactly the way that it should now. And then it's just a question of what you do on hit. And what you can do is you can actually leave both of these in here, right? Because you might decide to switch between a kinematic system and a rigid body system. So that's fine. You can do something like do, or just call it detonate. So from each one of these, you can just call detonate if you're not sure. Or again, if you want to be flexible, you respond to the events this way, but you do your actual logic here. So one thing we're going to do is we're going to destroy ourselves. And again, we probably want some sort of explosion prefab, right? A public game object, explosion prefab. I mean, this is a rocket. It should have a nice, satisfying kablooey when it goes. So we're going to destroy ourselves. Before we do that, if this is not null, then we can instantiate that from our position and quaternion.identity, so no rotation at all. So if we have an explosion, do that. Furthermore, our object which detonates on hit should do damage to stuff, right? So remember, in our performs attack, this is where we do damage. This is our raycast. We do a raycast, we figure out what we're hitting, and then we do damage instantly. But in our perform attack projectile script, all we do is spawn a projectile, and that's it. We walk away. So our projectile is the thing that needs to know how much damage it does. Now, how much damage do we do, and how do we apply it? Well, think about these games. These are rockets. We usually have these things explode. They should actually hit many things simultaneously. But the thing that it's right at the center of the explosion should take more damage, right? And things at the edge should take less damage. How on earth do we do that? Well, a couple of things. First, let's go ahead, public float, and we will call this damage. And we're going to use a nice big number. We're going to actually set it to 200 damage. This is the damage, damage at center of explosion. And then public float explosion radius. We're going to say it has a 3 meter or 3 unit explosion radius. So we want to take all objects that are within 3 units of our position and apply the damage to that. Okay, we can do that. That's fine. So what are we going to do? Well, there's a few different ways of doing it. There are one way you can do is gameObject dot. You can just kind of find all objects. Especially, you only care about objects that can take damage, right? So you can say find objects of type, and then you pass it a type of has health. And what this will do is it will return you an array of has healths. So all objects currently in the game that have the has health parameter. Yeah, that will work. And then you just, and then you can check the distance from there, because it's the mono behavior, which means you have access to the transform, so you can check the positions. That's one way of doing it. This can certainly be a little bit slow if you have a lot of objects with has health, because you're literally checking every single thing in the level. The other thing you can do is physics dot, what's it called? Overlap sphere. So overlap sphere is kind of cool, because you're using the physics system to say, okay, here's my position. And here is the radius, explosion radius. And this will return, oops, I lost my, my little pop-up there that was telling me the parameters. What's the return type on this? It returns an array of colliders. So this will return all colliders within that radius, assuming I'm doing this properly. Well, that's great. So we know for sure that we're only getting those. And the physics system is constantly sort of partitioning the world so that it knows a little bit faster. It doesn't have to loop through every single object to know if it's within that radius or not. It's a little bit more optimized to handle that for you. So this should be faster in theory. I mean, if you're not sure, test. So for each collider, C in colliders, we can do something like C.getComponent. We still only care about the things that have health. So each collider in radius, we're going to try to grab its has health parameter. So if h not equals null, then we're going to do damage to it. H dot receive damage. Well, how much damage? We don't want to apply the full 200 to everything in the radius, probably. I mean, I don't know, maybe it's a different kind of gun. Maybe it's some sort of black hole generator, in which case, yes, absolutely everything in the radius should take maximum damage. In our situation, we're happy to decrease it based on the distance, based on all kinds of things, right? I guess it should probably be an inverse square. That can work. So, okay, float distance is equal to vector3.distance. All right, so we have our position, transform.position, and we have our colliders, transform.position. So now we know the distance between the two. So we want the amount of damage that it takes to be the damage divided by the square of the distance. So a couple of gotchas with this. So there's going to be a fall off here, right? So things in the very middle will take a lot, and then things further away will take progressively less, and it'll drop off sort of, you know, on a curve. That's one possibility. This is not going to be right, though, because this isn't taking into account our radius. Plus, I mean, you've got to be ready for the division by zero problem as well. I guess we want it to be a ratio of the radius. We already know we're in range, so I guess it's distance divided by radius. Whoops. So if the distance is 0, so we want the explosion radius minus distance divided by explosion radius. So float, this would be damage ratio, I guess we can call it. So if they are literally 0 away, and then we divide by radius again? I think so. If they are 0 units away, this will just return the explosion radius of 3. If they are... Oh, it's 1 minus. That's what we want to do. 1f minus that. Okay. So if they are 0 units away, this will be 0. So this whole thing will be 0, which means they will take 1. So the damage times that is fine. And then if they're at the maximum range, which is 3, this will be 3 divided by 3, which will be 1. So 1 minus 1 will be 0. So they'll take 0 damage when they're at the edge. And then somewhere in the middle, they will take somewhere in the middle amount of damage. So yeah, it's not, you know, is this sort of fall off the correct kind of way? Because this will be what, a linear fall off, right? Maybe, maybe not. Who cares? You can tweak it. You can do different things. You can do squares. You can do roots. You can do whatever you want to sort of get the damage curve to feel kind of right. Maybe you'll do something logarithmic. I don't know. I don't care. But that should work. Maybe. Detonates on hit, 300 damage. Good. We've got a rocket in there. Make sure to apply the changes to the actual prefab. Let me reset the rotation here and then bring it back down to the right kind of general height. Move it over here, grab the rocket, line it up. So this rocket is lined up with the red, so when I hit play, it should smack into the red and destroy it. And possibly the ones near to the side as well. Boom. All right, well, the red definitely went. So if I tweak the radius, actually, I got another idea. Take this cube, duplicate it. Take this cube and duplicate it. I think if we hit play now, will they be close enough to be killed? Nope. Let me change the radius here. Doing it seat of the pants like this is not right. What I should be doing is actually looking and thinking, oh, all right. It seems to be working okay. I'm trying to find that sweet spot where it just destroys some of the ones in the middle. There we are. And in fact, what I should do is have these things report how much damage they take. That sounds like a good idea. So when something takes damage, debug.log. Let's put a log entry so that we can clearly see how much damage everything takes. There we are. So one of the things is taking 155 points of damage. That's the thing right in the middle. And the two on the sides are taking 122 and 124 respectively. And then the things on the edge are taking 69 and 75, which is not enough to kill them because they have 100 hit points. So that works out very well. There is one gotcha in that right now the center point of our explosion is at the origin of the object, which is right here. And really we want the center point of the explosion to be at the collision point. So we can do that. So we need a collision point. Well, or do we? I mean, in a way we do, but in reality, these things sort of detonate from the warhead, right? Which would technically be at the tip here. So you can think of all kinds of different ways, because our on collision enter, this gets a collision, well, this gets a collision object, which will describe exactly where the collision occurred. The on trigger enter does not get that. Instead, it just gets a copy of the other collider, so you at least know what you hit, but it won't tell you exactly where it hit. So with this, yeah, what we might want to do is detonate. You know, we could have a vector 3 here, I guess. Detonation point. And we can just simply scooch it forward in the z-axis by, how long is this thing? So it's 0.2 from the center here. So we can scooch it forward by like 0.15 or 1.5. No. 0.2, no, I was right. 0.15, and that should be a little bit more, right around here should be the explosion point. So the detonation point, and then, so when we instantiate our effect, we can actually center it there, and then here, use that for our calculation as well. So then we can hit play, and it should just mean that the center damage should be, I really need to save this in a thing. Vector 3 explosion point is equal to that, and then we will just use this here, this here, this here. There we go. This is such a trivial thing. I should have left it out because it's just confusing things, but there we go. So now it's just going to be a little bit more true to where the source of the explosion and the warhead might be. I don't even think that's something you ever have to think about. But, you know, if you're that sort of person, there you have it. And of course, if you use this as an actual physics enabled thing with like you know, an actual rigid body, and use forces to propel this thing, well then it will trigger the on collision enter, and this will give you the exact coordinates of the collision point, and then you could use that as your source of your explosion, even though that's not where the explosion happens. It happens at the center of the C4 in the warhead of the rocket, or however the heck these things work in real life. But there you go. Oh, and I guess this rocket, again, make sure to apply, good, delete, move back. So now I have a rocket that is shooting within myself. So we're back at that problem. And this one is a little bit harder to fix. And you can see if I click, it does, like, briefly a rocket appears, but the problem is it instantly triggers the on trigger effect. So what do we do for that? Again, you know, there's all kinds of different things that we can use. We can ignore the collision with the self. So we can, when we fire the rocket, we can save what the source object is so that we don't self-collide or anything like that. In this, I think what we're going to do is we're just going to offset it by forward by 1 unit, so it'll actually spawn out slightly ahead of us, which should be okay. Again, if you're hugging a wall, then it'll instantly detonate as soon as it hits the wall. Yeah, okay, and it's triggering against the ground, which is great. If we go over there, good. I mean, it's probably a little slow for a rocket. Well, there's no probably. It definitely is a little slow for a rocket. So let's kick the speed up a little bit more. So we got our rocket engine. Let's make it 3 times as fast and see how that feels. Good. Now, there is the possibility, especially if units move, that this will pass through your target. And we could probably fiddle until we ended up with a case, but you can imagine what might happen is the rocket fires. Let me get a rocket back in here. The rocket fires, right? It fires out. It's traveling at such a speed that it goes from here to here to here, and then the next frame it travels to here. Because our let's say we're on a computer where the frame rate sucks. You know, we're only getting 10 frames per second, and we're moving at a speed of 30 per frame, which means every frame it's moving 3 units, right? Well, these boxes are 2 units wide, I think, so it's entirely possible that it'll go from here to here and never trigger the on trigger enter, right? That is entirely possible. So what the heck do we do about that? Well, what you can do, and what you probably should do, is every frame, and technically this can be on a fixed update, I suppose. Void fixed update. You should actually do a raycast. You should do exactly the same as the perform attack. Well, not exactly the same, but you should do a raycast like this, except instead of the camera position, use our own position. Okay? Use our own position and our own facing. Something like my transform.position, my transform.forward, shoot a ray forward that is the same length as the amount of time between updates. And I guess if we're moving on fixed updates, then we don't actually have to worry about frame rate lag, now that I think about it, because fixed updates by default will run 60 times a second. You can change that in your project settings, time settings, the fixed time step. Oh, sorry, 50 times per second. So every 0.02 seconds, so 50 times per second, this will run. So unless this was running at, you know, a speed greater than 50, basically, you're not going to have that problem. But if you run into that sort of situation, I mean, one way to fix it is to decrease your fixed time step, so to run your physics simulation more times per second. But a lot of CPUs can't handle that, especially as your game gets complicated. The other way is on your fixed update, shoot a ray forward. And when you do your physics.raycast, and you fire your ray, and it needs a distance, you set the distance based on your speed and the current update rate. So, or slight distance forward. You can say, you know, because you can imagine that maybe there's like a short little antenna in the front. You can just like raycast a distance of 0.5f or some damn thing. It doesn't really matter. Maybe your speed. So whatever our rocket engine speed is. So, you know, some speed times time.delta time. This is the amount of time that we are traveling, the distance that we are traveling each update. Each fixed update, we're going that far. Well, throw a raycast that far ahead of us, and then use that to trigger our detonate. All right? If this, then freaking detonate. If we're going to hit something next frame, do that. And then this might not trigger, but then on the next frame, we might end up doing the on trigger enter. These are different ways that you can kind of trigger your explosions, and they can avoid some of those problems. This probably won't be an issue, again, unless you're going really, really fast. But if you're going so fast that your projectiles tend to like poke through things, well, not only is raycast the way to fix the projectiles, but frankly, you probably want to be using a raycast instead of a projectile. Again, make it look like it's a projectile visually, but actually do all your logic using the initial raycast. And then you program in your projectile to like close the distance between you and the other thing in, you know, like 3 frames, but you already know where it's going to end up. Then you don't have like on triggers and on collisions on this thing. You just know that, well, in 3 frames, I'm going to reach my destination. So that's when I do my explosion graphic or something to that effect. And you've already programmed in which things will be hit, or, you know, little things like that. There are ways to work around. These are pretty edge casey things, and you're probably not really going to run into them. And as is right now, we are in good shape. What you could do is on our first person controller, we could actually stick our perform attack back on here. And we could say that perform attack works on our left mouse button, then our perform projectile attack works on the second mouse button. Probably you don't want to have this hard-coded. You probably want to have a public int to choose which button is which, but now we have both guns active. So I have my direct attack, oh, which is not, oh, right, my debris prefab. Let me stick that back on there. Hit this again. So there we go. Boom, I can double tap anything to have it die, and then I can right click and throw out a missile. That's another possibility. What you can do if you have lots of weapons and you want people to be able to pick up pick up weapons, well, you could literally have it set like which one of these is active. You could have, you know, public bool is active weapon. Set everything to false by default. And then you could loop through it. And probably you want, you probably want inheritance and different things. Again, this is so specific to your various implementations that it's hard to generalize here, and I'm trying to keep this tutorial very, very, very generalized. Again, if you want to see specific implementations, well, my game does not have multiple weapons, but if you do check out that Let 'em Dare entry, the AAA FPS Game of the Year shooter, then you will see specific implementations of the raycast attack. So you can take a look at that. But there are other tutorials or other demos out there available for different effects. And that's the thing, like, you sort of just go shopping around for different effects that you might want to see and take a look at that. And if you do have any questions, please don't hesitate to ask down below. I try to respond to as much as possible. You can also email me at quill18@quill18.com if it's a bit of a longer message, or if you need to send me an attachment with any code. I don't have time to look at absolutely everything, or rather, I don't have time to respond to everything in Force. I do read 100% of comments that are left on my channel, or sent to my YouTube inbox, or emailed to me, but I don't always have a chance to respond in great detail, especially if it's a very complex question, but I will try my best, I promise. Anyway, that brings us to the end of this particular tutorial. We are going to be going back to a couple of slightly different topics next time, outside of the first-person shooter realm. Well, not really. We're actually going to be looking at advanced artificial intelligence, and actually we would probably do it with AI kind of enemies and have them run around and respond to you, and we'll take a look at how that works. See you next time, folks. Bye.